In 46 through 54, refer to the Tarski world given in figure 3.1.1, which is shown again here for reference. The domains of all variables consist of all the objects in the Tarski world. For each statement, part A says indicate whether the statement is true or false and justify your answer. This says there is a circle X and there is a square Y such that X and Y have the same color. So this is an instance in which both quantifiers are existential, which means we just have to find one circle X and one square Y such that X and Y have the same color. And that's pretty straightforward. We can pick X equals B and Y equals H. And so that means part A is true. For part B, we have to write out the quantification illustrated in example 3.3.10. So we're making two existential claims. So I'll put there exists an X and there exists a Y. First, we want to identify what this X and Y are. X is a circle, so we would say circle X. This proposition is true precisely when X is a circle. And we have to say that Y is a square, which we can do by saying square of Y. And then we have to say that X and Y have the same color. So we'll say and same color X comma Y. Now, if you notice in this entire statement form, now you might notice that in this entire statement, we don't actually specify what X and Y are, even though we did in part A by showing that B is X and H is Y makes the statement true. For part C, we have to write a negation for the given statement. So we need to negate part B. We start by swapping the quantifiers from existential to universal. And now we have to negate circle of X and square of Y and same color of X and Y. And to negate all of these and operations, we have to use De Morgan's law. So we'll negate each component and we'll swap the and operations to or operations. So either X is not a circle, or Y is not a square, or X and Y don't have the same color. Thanks everyone, and I'll see you in the next video.